Hi guys, today we're going to look at how ionic compounds are formed. And in order to do that, we're going to be using Mega Bloks or Legos. They come in big bags and I don't want you to mix up those Legos. There's lots of different kinds and colors, and that's going to become important to us as we're working through this. The first thing I'd like you to remember is that positively charged things are attracted to negatively charged things. Now let's remember where we left off. The other day we were talking about sodium, and here is a sodium atom, right? A sodium atom has a neutral charge because it has 11 protons and 11 electrons, and those cancel out. But a sodium atom explodes. Pure sodium explodes in water. So it's not really stable. You see, it's got this one outside valence electron that it's really trying to get rid of. Because once it loses that one valence electron, it becomes a sodium ion. And a sodium ion has 8 valence electrons. But a sodium ion doesn't have the same number of electrons as protons. So a sodium ion actually has a positive 1 charge. It's got 11 protons and 10 electrons. So there is a difference here having to do with charge and stability. Things can have a neutral charge but not be very stable, or they can have a charge and they can be very stable. Stability is that 8 valence electrons, or 2 valence electrons if you've only got that one inner shell. So knowing that, we can look at some other compounds. So let's take a look here at this picture on the screen of magnesium and fluorine. Magnesium has 2 valence electrons that it's happy to give up, happy to get rid of. And fluorine has 7 valence electrons. So it's looking to gain that one more electron to make its shell full. Now, once magnesium gives up its electrons, it becomes positively charged. And when fluorine takes in an electron, it becomes negatively charged. Positively charged things and negatively charged things attract each other. But sodium, and in the case of this unit, chlorine, is a 1-to-1 ratio. Sodium wants to lose 1, chlorine wants to gain 1. But that's not what's happening here with magnesium and fluorine. So let's take a look at how we can figure out how these ones come together. We're going to use these Lego bricks to help us to determine ratios. You see, the Lego bricks have these raised knobs on them. In this case, this is calcium, which is a lot like magnesium. It has a positive 2 charge, and it got that because it lost 2 valence electrons to become a calcium ion. Now, a calcium ion or a magnesium ion is looking to find a negatively charged ion to pair up with. So it donates its electrons to something on the other side of the periodic table, like chlorine, or in this case, fluorine. But magnesium doesn't just have 1 electron to give up, it's got 2 electrons to give up. So it actually needs to find 2 fluorine atoms, or fluorine, they're going to turn into ions, to bond with. So it gives 1 electron to 1 fluorine atom and gives its second electron to another fluorine atom. And it becomes MgF2. See, if you just had Mg and F, they wouldn't cancel each other out. You'd have a positive 2 charge and a negative 1 charge. And what we're after is neutral compounds. They're trying to form neutral compounds. So how do we do this with these Legos? You're going to choose a negative ion, and you're going to choose a positive ion. So I've got fluorine here and calcium. So here's a calcium ion, and here's a fluorine ion. What I'm going to do is I'm going to put these together. So calcium needs to bond with fluorine, but you need to bond them in the correct bond ratio. So you need to have 2 of these for every 1 of these. So we get, much like the magnesium, Ca plus 2, F minus 1, but they form Ca1, F2. I need 2 of these for every 1 of these. Okay, and I can do this with lots of different examples. How about sodium, our favorite that we've been talking about? When sodium gets together with fluorine, it's just a 1-to-1 ratio. There's 1 sodium and there's 1 fluorine. That's the ratio. This is sodium fluoride, so NaF. What about oxygen or oxide, this says? O minus 2. What happens when that gets together with a sodium? Well, if I put 1 sodium with it, it's not enough. So I need to dig through here and find myself a second sodium. So now I have Na2O. I need 2 NAs to balance out every oxygen. So we're going to use these Lego pieces to show us how to balance these charges. Let me show you how they might get a little bit more complicated, all right? Because any positive charge can fit with any negative charge. Here's Al plus 3. It's kind of hard to read, but this is aluminum. Aluminum has 3 valence electrons, which it loses to get a positive 3 charge. Now that's fine if I'm putting it with fluoride, right? I just put 1, 2, 3. But what if I want to make this a little bit trickier? What if I want to put aluminum with oxygen? These don't balance out, so I'm going to need another oxygen. So I have 2 oxygens now to 1 aluminum. Still doesn't balance out, so I need another aluminum to balance out that last oxygen. So this is aluminum oxide. Aluminum oxide has 2 aluminums, or Al2, 3 oxygens, Al2O3. So aluminum has a positive 3 charge, 3 dots. Oxygen has a negative 2 charge, 2 dots. There needs to be 2 aluminums for every 3 oxygens. And the reason is because aluminum is donating its electrons to oxygen. We just need to make sure we have the correct number of oxygens to cancel out the correct aluminums. So this makes the compound called aluminum oxide. Okay, good luck. Go ahead and use these to make as many combinations as you possibly can. Any negative ion can go with any positive ion. It's just about having the correct ratio so that their charges cancel out and you have a neutral compound.